Here in this canvas, first we'll prepare a simple model file and then we'll convert that simulation model into the C code, and that is a very simple process. So first of all, let's start with preparing a simple model, and for that let me bring a constant block, and then I'm going to bring sine wave, right? So I have one constant block, one sine wave, and then I'll bring one relational operator. So this is our relational operator, and then we want scope. So these are the things that we want. Basically what we are going to do, we are going to compare these two things and we'll see the resulting scope, and then we are going to generate code for this. So you can simply imagine that you have one logic, and using that logic you are going to generate some signal. So this is your simulation, and the same thing you want to write as a C code to program your controller, right? So the same thing you can transfer it to your controller. The same C code which we are going to generate through this, that you can directly implement into that controller. So let's set the parameter, it's 1, that is fine. Amplitude, let's make it 2, right? And we'll take one more relational operator, constant block, and sine wave. But here instead 1, we'll make it -1. One tip I'm going to give you, that in scope, if you want to add second signal, you can directly bring it to the scope and it will automatically make another terminal for the signal number 2. Okay, so our simulation is almost ready. Let's save this file and we'll name it as code generation. Let's observe it. It is not looking appropriate the way we want. Okay, I got it. The problem is with this frequency, right? Let's make it 7 radian per second. And now that's fine, it's looking both the signals that we are getting, right? 1 and 2. So now this much is fine. Okay, so now we are going to generate the code. What I am going to do, I am not going to do any setting. So without doing any setting, we'll directly jump into the generating the code. And then we'll have some error, and then step by step we'll solve that error, and then we'll reach to our final code. So first you need to go to the configuration parameters. In that you need to go to code generation. Here there are varieties of system that you can select, right? By default it is grt.tlc. We will keep it as it is, we will not make a single change, right? And then MATLAB by default it will suggest us that instead of this system target you should go to something else. And then we'll go to report, create code generation report, commands, symbols, codes and interface. We'll keep it as it is. Okay, and then we'll press Ctrl B, and then the diagnostic viewer, it shows us some error. And what is that? First is, you may configure the solver option for fixed step solver with an appropriate integration algorithm. So we'll open it. So that's what I'm talking about, right? This type of error it will show when we have not set our initial parameters. So instead of these variable steps, we need to make it a fixed step, and here we need to define any appropriate solver. What I am going to take is this ODE4 Range Kutta method solver. So the first issue is solved, and then it shows select a target that supports a variable step solver such as rsim.tlc. So instead of that by default grt.tlc, what we're supposed to do is we'll go and select rsim.tlc. So here it is rsim.tlc. Okay, that's fine. And then you can use embedded code quick start. So we'll open it. This is embedded code quick start. You can use this app from the app store of this MATLAB, but we are using it from here. So our system model, that's fine. Let's jump to next. Which code we want? C, C++ or anything else? So we want C code. The next is deployment. These are the analysis of our code. The analysis is complete. These are the basic detail of our system. And here you need to select execution for efficiency or RAM efficiency. Generally for small system, execution for efficiency, that's fine. And here these are the different files that it will generate. Next, and the system is working to generate the code, right? It will take some time to generate the code, and here we go. Code generation is complete. View code generation report. So here we'll jump to the code generation report. So this is our report. These are the basic information of our generated code. System report, code interface report. These are the different things. What we are interested in, it is main file. It is ert_main C. This is our main C file. This is our code. This code you can use directly into your controller. So just copy this code and paste it in your controller, and you can use the logic directly.